introduce the weld tool in the ultimate extent. So yes, it's interesting.
Okay. In my case, normally for shape we are not counting. Yes, because this is, if we compare the area of the weld compared to the whole structure area, this is nothing. If we compare the weld area to the whole cross section of the shape, this is nothing. But in our case, this is too big because we have small cross section. So the weld is important. Only for our box girder. The weld, if we make a ratio between this weld and to the shape, this is nothing. But this weld to our box girder is something. So from this point of view, I start to think, what about the effect of this weld shape?
But you modeled the weld tool using an equivalent cross-section area.
Two approaches, one equivalent and one triangle.
Yeah, this is the new way because you also have some reference to mention this method to take in the influence of weld tool into account in this way, using equivalent or cluster area.
This is assumption. It's not a real thing. This is assumption. How to introduce this welding in thin calculation? I find this easiest way in to be with cross section more or make it only increasing the thickness at the connecting node, only connecting node, or to increase only the stiffness a little bit. Uniformly distributed.
Right. And then I also come to chapter 3. I think on the page 107. We have a chapter conclusion. The calculated modulus of the moment curvature relationship used for the stress and the strain. You also mentioned on the page 125. So you mentioned that strain and stress-strain relationship was transformed from the bending moment and the curvature relationship. So I'm just wondering, because on the figure of moment and the curvature, there should be the product of EI, right? And for the stress and the strain, it's only for E. And how did you differentiate the contribution of E and also for I, taking the quotient into account?
Okay, this is it's already concluded here from the cross-sectional area itself. We have the calculation. This is elastic. We have our calculation, and we have this reduction due to severe corrosion. The reduction of the moment of inertia due to only corrosion reduction, this is thickness, we have around this 47% reduction. In case of bending moment in the end of the linear bar, we have around 72% reduction. This is, we are not talking now about curvature, this ultimate point. So here we have difference around 25% from where? If we have the same thickness reduction.
So you think the 24.7% is from elastic?
This is my observation. This is my observation.
Right.
And should be confirmed, and more tests should be done, for sure.
Okay.
And for sure, tensile tests should be done. But could be all of these things in the future.
Because when we come to the elastic modulus, that is based on my experience. Elastic modulus is majorly dependent on the microly the atomic distance.
Yes.
So that means even for stainless steel, the elastic modulus is almost the same as a normal steel. So from that point of view, yes, I think more testing have to be done to confirm or to support this conclusion.
And microstructure analysis for the corroded specimen itself should be done. Yes. But this is the first step, let's say, in the world in this field. So we have to have some doubts, yes. And should be confirmed, yes. So I already started, that's all. And someone should continue for me.
generally